Hello, everybody. Good evening. Please, if you can, take your seats. Thank you. It's a pleasure to have today one of our very few in-person lectures this year. It's always great to have the people that they are sharing their work with us here in the same auditorium where we can see our faces. We can eventually touch our bodies if necessary. So we're very glad. We have here a duo, as you see, an exceptional duo of two ladies. They are coming from Vienna. They are coming from the office of Coop Himmelb. So we have Karolin Schmidbaur, and I hope I pronounced that correctly. Karolin Schmidbaur and Efilena Baseta. Karolin is a design partner at the Coop Himmelb office in Vienna. She has been there since 1992. And she has been involved in many of the projects that the office has been working. She's also involved in the academia, and she's a professor at the University of Innsbruck at the Experimental Architecture and Design. I'm pretty sure that Karolin today will speak of a lot of projects that we have been seeing or using as references here in our work. And Efilena Baseta is, I'm really glad that we have her as well here with us. It's actually an ex-student of mine many years back. She then joined after IAAC. She joined the university, the Institute of Architecture in Vienna, and under a Marie Curie project of InnoChain, she completed her PhD. She also is co-founding partner at Numena practice with Aldo here, and she has been. She's also like a senior artist in the University of Vienna, and she's a computational designer at the Coop Himmelb. So this duo today will speak about hybrid formats of doing architecture. Much of the talk it will be related on how computation, how algorithms, how intelligent quote-to-quote machines could help us co-design with them. I guess they would also question the culture of designing with machines, as well as how we can add value to the designer's act, to the aesthetic part of architecture and the final outcome. So we're very much looking forward. Coop Himmelb is actually a practice that has been a pioneer in embedding digital technologies into the processes of design and manufacturing. They have been working with projects of different scales of complexity in forms, but also in materials and programs. So I think that we're really looking forward to see some of this work and the knowledge that you will share with us. Thank you, Karolin. Thank you, Efilena, for being here with us today. And please help me welcome both of them.
Thank you very much, Aditi, for this very welcoming introduction. We will do this talk together, alternating. And to start, I would like to say we titled our talk tonight From Sketch to AI and Towards Hybrid Processes. We decided not to show projects, just to show projects and explain them as the architecture, but to focus this presentation on process. So the way we work, including technology, as you have mentioned, but spanning kind of an arc from the beginnings of Coop Himmelb when work was completely analog, and also the value of the analog that has always been and still continues to be very strong in our practice. But make the arc all the way to now, where we have also started to experiment with artificial intelligence. and to see how in this combination we can actually propose a way forward that is even valid for the future, now thinking of the time we're in now and forward. To contextualize a bit, as has already been said, Coop Himmelb has been around for a long time, over 50 years of practice. You see on top of the slide the projects that have come out in these more than 5 decades of work. It's over 600 projects in total. And the timeline on the bottom. And the office was founded by 3 partners, Wolf Briggs and 2 other partners. 2 of them have left the office. Wolf is still as principal in the office, and myself, in a way, I represent already next generation Coop Himmelb, even though it's been since the early 90s that I'm part of this collaboration. And then Efilena, who is, maybe we can say, yet another generation, collaborating with us in the more recent years. To start talking about process, this small drawing is supposed to express an idea of how we approach work. Projects are not started with conceived ideas of an outcome, but really as a design research. We like to use the term open process. So it starts with an idea, with a hypothesis of a possible space, and that idea then is slowly translated into reality, developed and translated into reality using a multiple palette of tools, and guiding that process through principles that are applied from within and the context of the project. So an open-ended approach that always is driven by an idea and not by the means that these ideas are developed, or predefined means. So it is the idea that is expressed initially and then translated into models of various kinds, and then ultimately translated in reality. And what we would like to focus today on is this, showing different snippets of this process as it is partially a process of design or design development or prototyping, as much as a process of fabrication and construction. We think it fits very well in the context of the work you're doing here at this institute, focusing a lot on fabrication, but we do also include in this process this idea of design and how the earlier stages of sort of conceiving of the idea and translating it into architecture.
So we have selected several projects to show today, but not, as Karolin said, not to really show the project, but actually relate the technologies that were around at this time that the projects were developed. So in this slide, what we can see is the black timeline with different technologies, and when these technologies started to be implemented in architectural offices. So the office experienced the change from the 20th to the 21st century. And as we go to the right of the diagram, we can see technologies such as artificial intelligence or photogrammetry or robotics and virtual reality that I guess you're all familiar with these kind of technologies and you use them every day in your project. However, if we move to the left side of this diagram, we start to see things like a copy machine or a fax or the digital printing or SpaceArm or CAD. So all these things that we take given today, and what we try to do in this lecture is contextualize, so show examples that architectural examples that were realized before. And how these technologies inform the buildings formally, but also the construction process.
So we'd like to start with a quote by Pallasmaa. The role of the fundamental, unconscious, situational, and tacit understanding of the body in the making of architecture is grossly undervalued in today's culture of quasi-rationality and arrogant self-consciousness. It's a little bit of a bold statement, but it's taken from the book The Thinking Hand, focusing on the intelligence of the body that we have in the direct touch that we have with the work that we do. So a kind of mantra that has been at the core of the work, as we would take the position all the time, but connecting to this then are the digital tools that over time we've acquired into this process. So the fact that Pallasmaa is now in our observation coming into the discourse again, maybe is showing as an expression maybe of this era we're in that many call post-digital, that maybe this hybrid way of working, of giving revalue back to the body, is a way forward in a feedback with the digital world. So on the left, we see a person sketching, and on the right, we see a robot mimicking or sketching with the machine. And obviously, we can transfer the sketch to the robot and mimic the sketching, but the direct transmission of an intuitive thought that is coming directly from the body into the hand is disconnected through the machine. So there is a difference in the intelligence of the hand as it is directly connected to the work that we do with our bodies, and the work that is somewhat removed from our bodies through any kind of technology or digital means.
So now we will do a small test. I want all of you to look at this picture and tell me what you think or what you see. Yes, correct. So what you experience now is a automatic thinking mode. So it's a fast mode. So it takes some seconds or milliseconds to recognize that this is a woman, that she's angry and she's about to say something. If you look now at the screen, you see a mathematical problem, right? You all recognize immediately that this is a multiplication problem. And now I would ask you to engage with this multiplication. Yeah, I don't know if anybody had the result without using the phone, but what you experience now is actually the slow thinking. So the conscious comes into play when a task is more, let's say, strenuous mentally. And why we did this exercise? So there is a book called Thinking Fast and Slow, and actually talks about this two process of the brain. It's written by Kahneman. He's a professor of psychology in Princeton. And he says that in the thinking process, there are two systems. One, the system one, that is the intuitive and fast system, that works all the time and is effortless. And the system two, that is the slow thinking, and it's activated only when it is needed. So actually, we think of ourselves as a conscious entity. So we think of ourselves as the system too. But the truth is that most of the time, is the system one that is working. So now if we relate this with a design process, actually what we think is a good to have is to combine these two processes, so both the intuitive and the conscious process. Remove it. Okay. So yeah, if you were wondering what is the result of the multiplication, yeah. So talking about this intuitive and conscious processes in the office, we started very early to experiment with this idea of activating the unconscious and doing these experiments about transferring the intelligence of the hand and the body into the drawing and into the design process.
And obviously now, as we relate this back to the idea of the open process and the multiple tools, as more and more tools become available, this becomes a constant feedback between the analog and the digital world. And it is the feedback and the coherence between the two systems that actually gives the answers, or sort of makes the project advance. When we look over time, then in this sketch we see this kind of feedback loop. So you have the analog as a base process, because developing architecture is essentially a task that is within the physical world. So predominantly the work is in the physical realm. And if we think of a model in an abstract way, any kind of artifact, we do an abstract artifact to develop this work. It goes from small scale, it gets developed all the way to large scale, to 1-to-1. But within this is this feedback loop with the digital world that over the life of the project, as well as over the life as our tools grow, is a more and more frequent, more and more oscillating, and more rapid process, making the communication between the two worlds up to much more intricate fusion of the two. And in that kind of translation and ease of translation is where the benefit of this lies. So when we look at this in a visual, we have in the center at the example of a project, this development of a very early model of an idea for a building, all the way to the real building on the right side of the middle row. And then the feedback between digital processes that feed into this process, but ultimately one that starts and ends in the physical reality.
So this is again the timeline of the work of the office. And we have selected more or less 10 projects to showcase how technology influenced the way we design and we build. So we will start from the 80s and we'll go towards now. So we will see different buildings that have been built different times in different countries, in different typologies and different forms. But what they have in common is that they all are driven by a specific idea, and they try to be implemented by different technologies.
And on purpose, we have chosen projects that are built, so we can focus both on design, aspects of design, and aspects of fabrication and construction. Starting in the 80s, late 80s, this is a very pivotal project for Coop Himmelb. This was even before my time. I started working in this collaboration right when computers started to come in. So this project is not one I know from direct experience, but at that time there was no there were no digital tools available. The focus is on the sketch, as you can see in the background of this image. A very emotional sketch of an idea for a building, and the drawing that is already rationalized into an architectural floor plan on top of that drawing, directly translating that drawing into the building. At that time, we always will show this timeline on the bottom, referring to kind of tools that were available at that time and influencing the work in a very important way. So here, all we were doing was using copy machines, drawing, of course, precise drawing and sketch drawing and model building. And for many people, of course, this is not even understandable anymore or conceivable anymore how one could work without the tools that we're all now accustomed to using. So at that time, there was this idea for a building or a space recorded as a drawing, the drawing translated into a model, and because there was always a belief that these quick study models embody a very important information for the building, in fact, contained almost all the information for the later development of that model into a building. The model is about this big. And so the models were measured to capture as much as possible their geometry and their essence into a kind of recorded space. And ultimately, and now we're making big jump, of course, into a large detailed model and all the way into reality. In this development of this project, this is a rooftop project in Vienna, one of the first larger spaces that were built. And you also see prototype construction features in this project, like curved glass, one-dimensionally curved glass in this glazed roof structure, or pneumatically opening windows. And you see on the right side what kind of labor went into figuring out geometry of such a building at that time without any computational help. So even the joints of complicated steel intersections were figured out in a large 1:5 model, as you can see, out of styrofoam, using the wire cutter actually for Shahar.
So it took 7 years actually to build this.
Yes, it's a very small project, very small scale. It took 7 years to realize, and I think it's something we see now. We can realize in 7 years very large buildings only in that kind of complexity, only due to the fact that we have tools available to bring them into reality. We're making a jump a few years later in the early 90s. As I said, we started having digital computing. This was, at the time, we went to Los Angeles because they were already using computers. And this is the development of a very small museum project. And we found a tool called the Space Arm in which we could record. Again, we're trying to capture the essences of a physical model, as you see on the table in that image. And we're trying to capture the essence of this model via a space arm at that time. So you were recording XYZ coordinates with this pen tool into a digital model that then was further developed in 3D. You see some rudimentary drawings, very simple polygons, and the digital model of that time, fully developed with structure and all the elements in it, had 12.6 megabyte. And it was actually a very interesting process without typical planning of floor plan sections and so on. The project at that time was already developed entirely digitally in a 3D model, Form Z at the time. And then on the right side, you see pencil drawings of details that were keyed into this computer model to figure out the geometries and the details of this building and the construction and assembly. So the same concept of digital and physical drawing is also used in the construction process. So what is important to mention here is that this museum is placed in the Netherlands, so it's on a canal. And actually, it's fabricated in a shipyard because the ship industry was much ahead at that time. So they could do more advanced implementation from a 3D drawing to a physical, let's say, in this case, metallic plates. And so what we see here is in the shipyards, the fabrication of steel plates with the integrated structure and some drawings that were used from the craftsmen. So it's a collaboration between the digital, so from the 3D digital drawing to the craftsmanship of the workers. There was welding involved in this process all over, and this is connecting different pieces of the structure by welding them. So it's planar plates, and they were all painted manually, and there was this pattern on the plate from the exterior, which was printed and then cut into some stencil, but it was then manually painted. And then all these pieces were put on site, transported by boat, and start to construct the different walls, let's say, of the building. Yeah, and here we see the canal and the final building. What you see on the outside is actually an imprint of the original sketch again onto the steel plates as kind of a building that wanted to be the embodiment of this idea of the drawing that was the original idea for the building. And again, we see the copier, still very rudimentary, the copier enlarged the sketch. That's how you see this kind of dissolution of these black patches on the face. So it's a direct translation of that sketch through copy enlargement into the scale of the building. We're jumping 10 years. We're now at the beginning, the turn of the millennium, and 3D CAD, so 2D and 3D CAD drawings were standard practice in offices. Standard practice for planning, I would say, not yet standard practice for construction. This project is located in Los Angeles, so in the US. There was a real disconnect between kind of the means of planning and the means of construction. You can kind of relate this in the form you were supposed to.
Yes, so the design of this building consists of this simple platonic, so this based on platonic solids. Some of them are planar, but some of them are curved. In this example that we saw here towards the right side is a truncated skewed cone. So it's a single curve geometry that is developable, and so it can be unrolled into a planar surface. And actually, we see that we start to implement curved geometries into the building, but they're still describable geometries. And this makes the fabrication and the construction easier because the pieces, all the panels for this skin, they are multiples and not customized, so they're not individual panels.
So the show kind of this idea of that planning is more advanced in construction. So in this project, we're still dealing with very traditional layered structures. We have primary structure, we have secondary structure in skin. very, very conventional construction site, and kind of a planning that we had to go on site and supply all the data because there was no three-dimensional tools yet used on the side of the industry. So what this means also is for construction processes, and maybe not yet again now with the knowledge we have today, not conceivable, but it means everything is planned, but construction has at least 2 or 3 phases that with a lot of lag time, because you erect primary structure with a lot of tolerances, then you measure, then you fabricate secondary structures, then you measure, then you fabricate final paneling so that it ultimately fits. And all of this we're now able to collapse in time, even though the complexity of the structures we are able to build is even growing. And then here, this finished building, a high school in Los Angeles.
So the next project started in 2003. Is the Musée de Confluence in France. And here we started to explore, we are beyond the CAD, use of CAD, but we start to experiment dynamic systems and forces as inspiration for the design process. So this building is located in the confluence of 2 rivers, and the water eddy that is created in the conjunction of these 2 rivers was used as an inspiration for the design process. So particle simulations simulating this water eddy took place, and later they were used as a spatial element that was a structural and spatial element placed in the main lobby of the building. And this is materialized into a double curve geometry and started with some material test for the conception.
But we can see now it's kind of the same time as the high school in the US. This building is in Europe, much more advanced already in terms of technology use in construction. And we still see a very, very traditional building assembly, secondary structure that is now, however, using double curved surfaces, very complex nodes and knots in the construction. And what we see emerging is the digital model in very complex construction as the central device for managing the work. Managing the work both on the planning side as well as on the construction side. So the digital model for all trades and for all for the entire planning team is the one central model that is the reference for the entire building to be constructed. In a way, this is the beginning of BIM technology, if you want. In our office, this is still Rhino models that are the reference models that are kind of organizing the entire building from the planning to the construction process. So this is the decade after the turn of the millennium, all the way into the 2010s. And another project that uses the idea of dynamic forces and animation as an initiator for formal ideas is the BMW World in Munich. Here, this idea or the image of a tornado was used for a roof structure. A tornado is this wind formation that just touches down in one point and connects to Earth, and this is what this structure does. In this double cone structure is what is the major vertical structural element, and you see this idea of the tornado translated all the way into this kind of twisting steel structure that makes up this very complex roof structure. Why we're showing this project, though, is another device that was very instrumental in that design process.
So actually, to convince the client to build such an extreme building for this time, the office wanted to use an animation. But the animation was not yet so much used in the field of architecture. So the process that took place was coming from the film industry, and specifically a firm from LA called Imaginary Forces around 2003, where we built a physical model in a scale of 1 to 80, and cameras were placed inside and outside of the model, recording path. And then this movie was augmented digitally in terms of lighting or people or more information. And so this is how this first animation was made. So in the left side, you see the camera moving, and in the right side, you see the finished animation augmented, also digitally. Yeah, and this is the bit. So now we're 2007, and recently additive and subtractive manufacturing have started to be used in the world of architecture, and this enables a lot of different possibilities. And this project is the Martin Luther Church, placed in Austria. And so the whole idea starts always from the sketch, from the hand sketch, and then is implemented manually in a physical model. And this physical model is then mapped in the computer. And this time is Rhino, so the geometry is completed in a 3D model in the computer. And then we have the possibility to 3D print this geometry, so this roof, that is the spatial element here, in a monolithic way using a 3D printer. And actually, this possibility of printing in a monolithic piece inspired the designers to construct it also as a monolithic piece.
So the roof, again, is constructed like a piece of sculpture. Again, was fabricated in the shipyard. The shipyard at that time actually had already opened up a division for architectural production, was able to do double curved elements in a much more economical way than we were still able to do it in sort of traditional industry. So this, you see images of this complex structure. Again, a plated structure. So steel pieces that are all cut from flat material. Actually very, very economical, because you just lay out all the stiffeners flat, cut it out by laser, and then they're welded together. Shipyard, again, is inspiring in a way because they were able to combine kind of high technology. They already had digital calculations, knowing how much steel plates, when they were bending them, would expand in the different directions so that the end seams would fit. But at the same time, using their experience in craft to bend these panels manually. So manual bending, but computed calculation of how to cut those plates is kind of an interplay to get these double curved surfaces into reality. Very emotional, I think, these images. The seam welding, so that in the end you wouldn't see, as you would see in buildings, panelizations and joints to get, in the end, this monolithic surface. So this roof structure with the skylights is completely fabricated in the shop, welded together as one piece, and then coated, of course, ground, primed, painted, and ultimately, in order to bring it to the site, it was cut up again into slices that would fit on trucks and transported across Europe down to Austria, where it was then reassembled. And we had sound for this, but I think we disconnected, right? Doesn't matter. And then lifted in one piece onto this base structure in the neighborhood of this, of these traditional buildings, all with their tiled roofs. It's kind of nice, the sound with it, because the way they had to park this roof in position was very tight. And this was real precision at minus 15 degrees in wintertime and snow. And I think the people welding it together in the end on site were lucky that they were welding, because it was producing a little bit of heat. So here's that roof, no seams, one monolithic structure, painted silver.
Yes, and exactly this, let's say, innovative construction process for these monolithic structures. You see, it's from the exterior and from the interior, from the bottom. Actually, it's interesting to see how it was finished for the interior of the building. And actually, a very old traditional technique using reeds as a substrate and plaster to cover it, so was used. And it's interesting to see that sometimes something very traditional and low-tech can achieve the best result also in a most economical way. And this is the finished building. So now we are still in 2007 with the Museum of Contemporary Art and Planning exhibition in China that was completed in 2016. And this was the time when we started to implement robotics or do some research about how robotics could be used in architecture. So the specific part of this building we want to focus here is this double curved structure that is placed in the entrance of the building. It's actually like a 3-story building inside the building. And it reminds Nis Kapoor structures, is made of stainless steel and is constructed through these ribs that you see on the right. And actually the construction consists of segmenting it into different parts and mounting these different parts into the plates.
So again, you have to imagine in the office we always we have these double strands. There are experiments going on with technology, in this case with robots, at the same time as projects are going on. And so then tests are being made of how these kind of technologies could be implemented in the projects that are currently being worked on. So for this piece, you see on the one hand artisans in China actually building one of these Anish Kapoor pieces by hand, and at the same time figuring out with fabricators how to actually possibly fabricate this object robotically. So here you see now no more manual press as we've seen in the shipyard, but now we're cutting and giving shape to these double curved panels robotically. And I leave it up to you to figure out how it was eventually built. So here we still see an animation and a kind of test of how all these different work processes could actually be given to the machine. So from cutting those panels, each in a different shape and form, of course, erecting them without any people or scaffolding, placing the panels, and fastening them. You cannot do fast forward. And then, of course, all the way to welding, grinding, and getting rid of all the seams. So this building is in China. It also had nice sound, so too bad. Yeah, so here it is.
Yeah, so as we said, this was the beginning of doing more research project around this topic of automating construction or reducing the time and the effort for construction process. And this is a research about constructing facades, facade panels without the substructure. So automating the facade process by robot picking and placing the elements and welding them together without the need of a substructure. So actually, it's nice to say here that parallelly to the real projects in the office, we run these research projects that are speculating what could be used in the future in the construction. So now we're again 2008, the same time, with the Pavilion 21 mini opera space in Germany, where actually Grasshopper started to be used in the office, and actually we have the possibility to design by data. So we can see workflows completely digital, so going, let's say, from the sound of the street to the geometry that is mapped onto the building, and then also fabricated within the office with CNC milling processes.
So the idea of this building was it's actually a temporary pavilion for opera, and is placed right next to a noisy street. And as we know from temporary buildings, they want to be light, but buildings that want to be acoustically feasible also want to be heavy. So the idea was for this form to not have the sound from the street enter into the building, but it reflected back onto the street with these polygonal surfaces. So that's why sound as a source was translated into this outer building shape for that little temporary pavilion built in aluminum. And the laser then was another tool that in the design process started to make a big difference. We're still building physical models, as you see in the top center, a small model for a small a life-size camera housing. And now the models are laser scanned. And what is really interesting is that, to me, this is the threshold of actually having a step into too much information. At that time, so you see on the bottom the scans, we're now not recording point by point as we were decision making sort of what we record into the digital, but through the digital process, we get millions of points, which then we have to decide how we rationalize them down, or whether we maybe build this detail that comes simply out of the scanning process. Both avenues obviously would be would be possible if we could figure out what this detail, other than maybe aesthetic issues, could be, why we would be using that detail. But here you see an example where this geometry was still rationalized, as you see on the bottom left, bottom right, translated into in a polygonal skin, and then translated into, in this case, an aluminum structure.
So now we jump a little bit more towards recent times, 2014, that House of Bread project started again in Austria, where we start to implement more geometric analysis or performance analysis, optimization processes. So this building consists of, the main geometry of the building is this double curved shape that was analyzed in for different criteria, like the water flow of the rain, so how the building performs to the weather elements, or what the curvature means for the construction of the building, or also how this intricate shape affect the visibility of the building from different perspectives.
So we can now map and simulate environmental data and include them into the development of the work. Environmental data as well as further data for construction. So this project, which again came from an idea for a space, actually not for an idea of this outer form. And the decision was to build it out of wood, surprisingly so. As a monolithic, free-formed, self-carrying structure. So it's really a massive wall that is load-bearing, and it is constructed out of cross-laminated timber. So the idea was to actually, again, cut out of flat material segments that are milled, so that in the end you get a free-formed interior as well as a free-formed exterior. So you see how this envelope is cut in rings. Curvature is analyzed. Again, these rings are cut in segments so that eventually they could fit on trucks and be transported to the site. Here you see the first pass of milling with straight edges, and a second pass of milling, as you see on the left side, that then was a hyperbolic kind of surface to give this inner curvature. And all these pieces then ultimately just simply stacked, screwed together to make this this load-bearing structure. You see here inside the load-bearing layers of cross-laminated timber. Outside, of course, then is an entire rain screen skin. But actually, the idea then was, the decision was made to leave this wood exposed on the inside, and it is now basically fully wooden interior for this museum. So again, something nobody would have ever thought in this building, that we would do it out of wood eventually. I think it's, from what I know, the only building that uses wood in the office. But it came out of many different ways. Were actually investigated to do it in steel, and this was the most economical way to build this, to bring this building into reality. And ultimately, we were able to convince the client to leave it exposed. Of course, he wanted a white interior, but already the mock-up of this project was so beautiful that it was impossible in the end to cover this interior, or to even think of painting them, or even think of touching it in any way. And an exterior now of over 3,000 different panels. We don't have to do same size panels anymore, no more mass production. Everything is laser cut. So this shingled facade, we are able to produce economically without having to change the panelization or rationalize it more. So now we reach 2019, and this is the time that I also joined the office. And especially for this project, which is the Central Bank of Azerbaijan, that is under construction right now and is going to be completed in 2024. And there are already some years that artificial intelligence and machine learning start to be used in architecture. And this project, as a big scale public project, has also a very complex timeline and schedules, and is also a long process until the construction and also the construction, and is also a high-rise. And the most intricate element of this building is its facade, its glass facade. So due to this shape of the building, there are not only planar panels in the facade, but there are also kind of bent panels that are either triangulated to simplify the construction, or they're planar, or they're a little bit bent, so they used cold bending glass panels to fit the geometry. So these panels, they vary in terms of planarity and shape and size, but also they vary in typology. So some of them are opening, some not. They have different profiles according to the use in the different parts, the more open or less open parts of the building. We distinguished 15 different kinds of parameters or criteria that these panels are different. So let's say size, twist, curvature, typology. And these are visualized here in this graph. And actually what we want to use is cluster these panels into different families that could be constructed in a similar way in order to make the production more economic. And this is a neural network that implements dimensionality reduction in order to reduce all these various parameters and variables into one variable that could be visualized then in this outcome Daniel Bologan implemented this process. And here we see the final result, how the whole facade is clustered into these different families of similar panels. And yeah, as I said, the building is currently in the foundation, so we still haven't verified this process, and we start to go higher. So now we're experimenting with artificial intelligence. Our brain in this work, who is doing all the programming, is Daniel Borian. He's now at the University of Florida. And the way we approach this possibility of building a network of neural networks is, again, an idea that goes back all the way to this idea of the open process, where we're not interested in completely giving up tasks to the machine, but we're designing little partial processes that we can plug into our workflow in different parts. So we are testing how we can automate certain processes so they would cut out time. In other ways, we try to use artificial intelligence and networks like style transfer to build up kind of library for inspiration, and that could further influence the work or give us input that otherwise we cannot conceive in our kind of typical traditional thinking. So we have these different nodes. Some are trying to automate, like this one, or we call it augment, as we are using it for design input. Some are formal explorations, translating between models and imagery. Others are organizational explorations, and yet others are dealing with technical tasks, like Efilena was just explaining in the example of the bank in Azerbaijan. And if we go and, for example, you have to imagine, usually now we have to produce images of projects before we even know how we would develop them. So we try to train networks so that they, if we're only at the development of a model, learn from the buildings we have already realized, as are many, and from the many examples of how the language at Coop Himmelb is built to materialize things. We try to teach the networks of how we would materialize volume. So here you see a tower typology, but it could be also a different typology. So all this information flows into a network that ultimately allows us to draw from. And of course, we try to do this now within the work of Coop Himmelb that we already have. So for now, we're trying to use it as tapping into an intelligence that the office has built up now for 50 years in figuring out the translation of ideas into the built realm, and we try to enhance what we can conceive in terms of our own experience through the experience we get in addition through this universe of that we've created now inside the machine. I think I took over one of yours. I'm sorry. Not sure I made it clear. So here, this is the sort of what we call the Himmelblau universe of artificial intelligence. It is an entire cloud of possibilities for architecture that we can draw from. It has semantics embedded, so we can also query this kind of cloud for different specificities and sort of have it give us answers, as you can see in this in this short animation.
So actually, what you see in this, what you see here, what you see in this cloud, that is actually in this universe is actually a 3D space made of images, and these images are photos from the realized projects as well as augmented pictures from the AI. So it's a mix of real and produced by the AI images that are grouped in families. So all the images that you see there closer, they have more similar typologies, and there are ours that are more further apart. So they're somehow self-organized into different typologies and different semantics, and this allows us or the user to also explore this space. And actually, this is one example. So if we could input an image, like the image on the left of a building, and then the network through this universe, searches through this universe and try to give us different imaginary examples that are similar to this image.
So again, this is a huge database now that everybody has available, and the question is, how can we, without being experts, how can we give access to just people in the office to this network to explore it themselves, and to kind of lower the threshold between people using it sort of as a device to work with.
So how the designer can inform this automated process and interact with this process rather than feeding images and getting an automated result. So our goal is to try to really use it or implement it in our workflows for non-experts also. And this is an example of organization, of this category of organization and augmentation that works in the 2D realm. So there are several different plans from the office into this network. And right now what we're working is on the 3D realm. So working with 3D mesh data and trying to augment our design space in the 3D directly.
Of course, this is dangerous, because now we get into the realm of the machine giving us answers, and we have to still decide whether we want this or not. But the conclusion we have come to in all this work with imagery that we've shown before, that really what comes out is not much more than another sketch that is on a different level of order. Not a sketch we produce, but a sketch that is digitally produced that we yet have to interpret and translate into architecture just the way we would interpret the hand sketch. It is merely an inspiration and not really, because it is not really a three-dimensional answer as we would directly be able to use it. So where we're currently at is, and I want to connect to what we said in the beginning, this kind of, we call it multifactorial hybrid process. And now through this work in artificial intelligence, it has yet another layer. So we still use sketches, we still use models that are built in an analog way, trying to embody an idea. We use 3D printed outputs that inform further how this model could materialize, or milled models, which have a completely different quality that we can as well capture and translate into the next step. As well as now on another layer, we have the input that we get from inspiration through the AI, as you can see on the upper row, where we, in this project, decided to use these images for an idea of material transitions. This is a peculiarity that we see in these images coming out of this experiment, that our next step will be to see how we can really capture that quality and translate it into a three-dimensionality, and ultimately into material and material transitions. So I guess the question we would leave everybody here is, I think we made a point that we tried to make in a position, but do we believe that ultimately or at some point the pencil sketch will be substituted by these experiments that we can now do with the machine? Or can architecture with aesthetic values emerge through merely digital workflows? So our position would be this idea of the hybrid, this idea of the feedback between the two realms, as we were trying to make the point of the two systems that work together. And connecting back to this idea of what is the next step after the digital project. maybe the next step is really in bringing these hybrid conditions back.
But so it's an open question, but don't worry, in 2 days, tomorrow will be yesterday. So we will soon know the answer.
Thank you very much, Karolin and Efilena, for a deep journey to the history of the office, but also the potential to use this technology in unique in terms of form, no? Sometimes unique in terms of fabrication as well. Build projects. I think it's interesting the way that you're trying to integrate the advancements of technologies in the process of the work. Maybe before opening to some questions to the audience, I had a thinking. I'm not sure it's a question, and I really find very interesting the fact that, Karolin, you see the work of the AI and the outcome of the AI training or the machine learning, let's say, algorithm output as another sketch. No, I think that it's really interesting because a sketch is, as you say, the initial point of an idea, and this can become a project. My doubt, or let's say my thinking is when we train that algorithm with what, for example, we consider style, no? What we consider, let's say, aesthetic identity, and I wonder when we do that, whereas we're trying to somehow mechanize or automate something that is truly inspirative, no? That it is something that usually creates surprise. And whereas by doing that, we are missing an opportunity to keep on surprising ourselves by this, action of sketch that sometimes could, of course, bring, previous thinkings or ideas of a project, but could also be something completely different. So I wonder, whereas you are working on trying to create a companion of design that could create surprise rather than ideas that follow the same style, whereas you have thought about it.
I mean, to me, like I said, I think this is a dangerous point to be in because, I mean, the way I was seeing it, the sketches we get, of course, they are informed by the work that we've already done. This is not material that flows into these that is coming from the outside, right? So here we're mapping the idea of how we materialize buildings onto clouds or onto, like this image we're seeing, or onto the interior of caves, of like more organic morphology, but then the language of architecture merged with it. And I think what we put in is what is partially informing what we get out, right? And where I personally find, for example, these kind of images incredibly inspiring in what I said, this aspect of material transition. Not so much maybe also formal aspects. They're very interested. It's a little bit, I see it on the level of when we do scans of models, they give us different information and sometimes something happens. So the scans, for example, they don't observe edges very well. Actually, it's exactly the edges that they cannot read. So what does that mean? How we would maybe treat edges differently, or in these, where is this idea, where could that lead to in terms of structures that are seemingly less rational, or material blendings that make this idea of the detail as we know it, as a joint, kind of obsolete. And I don't really know how to get there yet. but it gives an impression of that, right? As we can see, this is very strange how things merge into each other. And so I guess how I would answer is it is still us that select these inspirations. There's thousands coming out of these processes, right? And there is the one that we choose to use. Similar as and so maybe this is on the positive side. It's still us that select these inspirations or let us be inspired by it. And it's still us that translate that back into something that is working in the architectural language. And so that would be on the positive side. On the danger side is we're subordinating ourselves to things that come out of automated processes. And so in our work, we have never done that, right? It was always subordinating the technology to something we wanted to do that comes from somewhere else, but not through that process. Does that make sense?
Can I add something? So to a more technical level, because you asked about the data set, of course, it's the really important data set that you give to the algorithm, right? And where lies the quality of these works or experiments is actually how much you can control the tool. Is the same with computational design. Is not only about using the tool, but is controlling the tool. And the more you work with it, and the more you're able to control, and not just transferring some styles, but actually understand the semantics of the work and be able really to control the output, then it's another quality.
Thanks for the presentation, and thanks also for this couple of days that we spent together to discuss a little bit about your trajectory, your experience. Let me also thank you for taking care of our student from the second year, Shahar. In fact, both Karolin and Efilena are following the work of Shahar, that is also trying to build a new stage, a new process in between the sketch and the realization of physical model. And he had the luck to be included, in hopefully he will be included in the next presentation, but he had the luck to be included also in this process. Looking at your presentation and also following a little bit the conversation that we had yesterday, I take for granted the input that you gave me. The creativity is the common thread in this experience. And it's evident that all this presentation at the end is also manifested that we don't need the contemporary technology to reach complexity. So complexity is something that has always been in the DNA of Coop Himmelb. And it's interesting also to understand what it really means beyond the geometrical and also the structural capability of building spaces so dynamic. One of the things that I understand that technology unleashed through this process was something that you already mentioned before, both you and Efilena. There was this capacity to switch from a manufacturing point of view from a standardized component to a series of diversified pieces that could at the end assemble this higher degree of complexity in terms of geometry that these buildings are now representing. But looking at the end of your presentation is it opens up another chapter of conversation on what is creativity and what will creativity be, because this process of sketches, dynamic sketches that we are looking at are processes where the machine encodes knowledge, how the machine encodes experiences and cultural heritage that you've been building so far. I'm reading now a huge book about the future of work. And it's the future of work. It's a very boring book. It's actually kind of an encyclopedia of automation. And in this book, one of the chapter that hit me the most was really the one about hybrid process. And in fact, in the history of automation, all the hybrid process, they were relying on a temporary collaboration between man and machine, ended up in favor of the machine until the machine was capable of checking all the boxes that the man could still provide at that specific time. Now, doesn't want to be, the beginning of a conversation that I would be very glad to skip about the role of architects in the future. But it's evident that we are not ready to pass the torch to this process of creativity. So since creativity comes back here, for sure we are opening a new chapter where at the moment the machine is providing an inspiration and intuition, but I mean, just let's be aware that there is a new age now, the new chapter that is opening and is starting. So I just wanted to underline, it's not really a question, just, a little bit, no, I mean, every time we were discussing yesterday, not to only have a pinpoint of question and conversation, but more an open dialogue. And for sure, this is a reaction. It's a future that evidently is unknown, but it's also very interesting to see how Coop Himmelb now is pushing now this higher level of maturity also on which is the role of this hybrid process of creativity.
I have something maybe to add to this, which is a little different, because when you talked about the machine in the end was winning, Daniel, when we were discussing your work, he pointed us to an article which was referring to chess, like chess masters playing against a computer, right? And so the outcome of the study was it's not the machine or the better player that determines the outcome of the game, but the process. And the process of, I'm not a chess player, of making the moves or how you interlink them. And so to me, again, that would speak for sort of the process versus the machine. I don't know. I don't know. No.
Okay. Cool. Okay, I'll look fast to be far from the microphone. Thank you again for the comments and the beautiful presentations. I learned a lot from your process thanks to the collaboration we have in the Master in Robotics, and in particular how you approach this technology and that you've shown here, in a touch of openness. You see the possibility, maybe me, of letting the artifact, the glitch, the issue that might emerge from a process, not necessarily as something we should look always for the perfection, but as an inspiration to drive more things. And you went very fast through the project in a very short time, but I'd like you to describe or to tell us a bit this moment of interpretation of what the material you have on the table. The glitch of the fabrication, the detail of the textures, the scan giving you points or edge. You started to mention this with Areti, with the question of feature that disappears, that appears, and how it became a dialogue with this technology more than just asking them to deliver just what you asked. If you could elaborate a bit on how you let this, I don't know, for example, this drawing that you have emerge or drive a new design on your products, or not products, that's not how to call it, but you have to materialize it, you have to solidify it, you have to detail it, and you make it look very easy in the presentation. Well, I think it's a long work that you had on the table to process it.
Of course, I mean, it is a long process, and it's always a very laborious process, right? Because the trick maybe is you start somewhere and you have an idea of where you go, right? You make something, whatever it is, a model, and maybe the model is It shows a certain idea. Then you scan the model, just to give an example. And you scan it with the intention of scanning that model, right? Because for what it was, it came out good, let's say. I mean, not always the first model comes out good, but let's say this one did. So you like it, you scan it, you say, this is it. And then in the scanning process, when you get the information back, you see something new. Like whatever in the surface of the model was maybe an imprecision in the way it was cut. It is registering in the scan in a way our eye was actually overlooking. So, because when we know how to look at models, they're made whatever they're made out of. And as we were making it, we weren't particularly focusing on, let's say, texture. But the machine brings out certain details maybe in a much more exaggerated way, and all of a sudden it is there. Or like I was saying, the edges are cut off and they're weird, and all of a sudden you see that is very powerful, actually. Or this brings us to a new idea. And so you didn't intend for that idea, but you intend something else, and then that is given to you, and that makes you take a corner, right? And take a new decision. And it can happen in a lot of ways. Also, when we were, like I was showing this last project, we were having the scan of the model, and we didn't really know yet how to, because the problem with scans, again, is they give you just surfaces. So we're doing a lot of work in trying to figure out how to re-geometrize these point clouds. Because if you just let it make it a mesh, you're done. You always have the surface, and then all you do is surface manipulation. So how can we materialize these points differently? And so let's say we take a passive materializing it, then you make a plot model, you 3D print it. It comes out with sharp edges of these polygons. Maybe you take the resolution down in a much different way. Then you mill it, same information, milled, completely different surface. It's very velvety, it's very soft. All of a sudden you start thinking, oh, maybe on one side we should make it, we use the sharp information, on the other side we use the soft information, or we blend it. And then we have this information maybe coming out of the AI process, where we start having that idea we could blend it. And to me, it's a process of seeing. Like you recognize something as having value, and then you try to capture that and translate it into architectural terms, right? Because often this information doesn't come out of an architectural realm; it comes from somewhere else. You translate it into architecture by making it something that works in the architectural language. Does that make sense?
Okay. They just tell me that I only have one question, but I have two questions here. So can we do one question after the other, and then you can try to, maybe, if it makes sense, to answer them together?
Thanks for the lecture. It's very nice to see how you are not afraid of new technologies throughout time. It's very interesting. I was going to ask about the AI training models that you showed, specifically the ones about 2D and 3D generations, not the ones about images. Does the software know something like that is a wall, or that is like a facade or something, in the sense that it would say that, like, you cannot put two walls in a, I don't know, with a certain width, or maybe, like, does it understand that that thing is an architectural term, or it's just based on imagery and it generates, like, kind of in a way randomly? That was my question. Thank you.
Karolin, just one, because we have very little time and we need to leave the building. We have one more question here, so we will do them together. Yes.
Thanks. I'm like a fabrication person to some degree, so for me, in the very linear process that you showed here, like from the beginning, the kind of also the slightly, I don't know, fetishization maybe of the genius sketch, and then everything that follows is let's say, to fulfill or to materialize. I think you use this word. Also, this kind of grand vision that comes at the beginning. So my question is like, when do you call the fabricator? Sorry.
That's
Mhm. Yeah, so that word fetish, of course, is a tough one. But no, I would say the interest in how to fabricate is there very early. These models that are called sort of this is it. Let's say let's try to build this. They are very small, and they're little massing models, little idea models, and often the thinking about how to make them or how to construct them or portions of it start then. And they influence very much what comes out. But to me, it's part of this whole process of allowing everything. So there is never an idea of how to exactly construct it, but rather in the dialogue, it emerges. I mean, sometimes there is an idea, like the idea from the shipyard. But as I was saying, for example, in the example of the House of Bread, the small museum, there was no preconceived idea, just simply that space. That space as an idea was there, but we didn't show in the process how much that actually changed. You still recognize from the very beginning that sort of the DNA of the idea is still there. What came out in the end has a lot of influences from all kinds of planning processes, and very much from this idea of, in that case, realizing it in wood. So I think actually this dialogue that happens in the very beginning from the drawings or model, it's not even always the drawing that starts it. I mean, it's just sort of a lot of other ideas sometimes start. It's something that shows the idea, right? It doesn't, and it is very open. It could be one idea could materialize in many different ways, depending on what you make out of it or how you like to see scale in it, or type a certain organizational type or anything. They're not so fixed. And so there is a lot of margin, and depending on how you sort of step by step rationalize it and what you see in it, this is what it becomes. And fabrication plays a large role in it. Just not as much as it would be in the beginning. We want to do something in 3D print, and then go from that, and the project evolves. I don't recall a project that has ever, like in my experience, started that way. But nonetheless, this idea of how to build it come in very early in the process. Just like talking to structural engineers, talking to having energy design incorporated now. I mean, 20 years ago, this was not as much an issue, but for 15 years, we've had these ecological influences coming in the project very early on. And same with fabrication, I would say. I would add that
most of.
Oh yeah,
Yes.
what was that question again?
AI.
Yeah, so it doesn't. No, it actually. I mean, the interesting thing again is when the AI misunderstands. So, for example, when we were showing this two, like having a 1 to 500 massing model, having an AI component translated into a materialized image, the most interesting results in my eye came out when we were feeding, let's say, frog perspective of models and having bird's eye perspectives of finished buildings. So all of a sudden, the network would read what was a frog perspective as a bird's eye, and something very interesting came out that you could think, maybe I translate that into another volumetric study or into a materialization, but I think these misreadings, they happen. But I would call those actually interesting.
And actually, it might not know if it's a wall or a roof, but what it can recognize is similar typologies. So based on the image.
Thank you for inviting us. And for me, I'm very happy to have been able to visit IAAC. I was very inspired today, seeing the work and seeing the different buildings and the school. It's really, it feels like a very, very nice place. Thank you very much.